All right, welcome back. In this video, we are going to learn how to solve a quadratic by completing the square. So there are three main methods that we can use to solve a quadratic. You guys already learned the zero product property. This video is going to be about the second strategy, which is completing the square, and the quadratic formula is going to be next week. So first, I want us to see how we can solve quadratics that look like this without needing to factor. So let's go ahead and look at the first one. Some of you figured this out on your homework from last week. I think it was problem 85D was one that could either have been solved by factoring or have been solved by taking a square root. So I'll do the first one for us. So we're going to solve this one over here. I'll call it 1. And we're solving for x. So I want to get x alone, so I'm just going to peel away layers. So I'm going to add 16 to both sides. So I get 16 equals x squared. And now I have to think carefully. So I need what number squared would give me 16. And we know that 4 squared could give us 16, but we also know that negative 4 squared could give us 16. And so that's why when we take the square root, we have to consider both the negative possibility, and the positive possibility. Why is that doing that? So in this case, we say that it equals plus or minus the square root of 16, gives us x, which is obviously either 4 or negative 4. Let's do the next one together too, and then I'll have you try the last two on your own. So we're trying to get x by itself, so we have to peel away the layers one at a time. So we're going to subtract 3. So that gives me 4 equals x plus 8 squared. I'm going to erase that. And then I need to take the square root of both sides. And remember, I need to take the negative or the positive, because whatever this stuff in here is, it could either be, when I square it, it's going to give me 4. So this could either be a 2 or a negative 2. So I've got plus or minus the square root of 4 equals x plus 8. So I'll break that up into two different problems. So 2 equals x plus 8, or negative 2 equals x plus 8. This should sort of feel like the zero product property, how you end up with two different possibilities. So the first one up here gives me negative 6. This one right here gives me negative 10. And real quick, I just want to show that both of those work. So negative 6 worked because it ended up being 7 equals 4 plus 3, which is true. Let's try with negative 10. Hopefully we can see already how this is going to work, because it's going to give me negative 2 squared, which is 4 plus 3, which also works. Okay, I want you to go ahead and try and do the next one over here. Oops. Take a minute and do that. Okay, I'm going to go ahead and do the steps. I'll do them relatively quickly. First, I subtract 5. Now I take the square root of both sides, and I'm trying to find some number that when I square it gives me a negative 5. This is never going to work. You can't take the square root of a negative number. So we say no solution, because the square root of negative 5 is not real. If you haven't finished the second one yet, pause again and give it a shot. If you have, then keep watching and I'll do that one. So here we're going to add 3 to start. And we're going to do the square root. So we're looking for x plus 2 to equal, And now 3 doesn't have a nice square root, so we're going to have to leave it as plus or minus the square root of 3. And that's fine. The square root of 3 is a real number. It's irrational, but it is real, so we can use that. So let's split it up into two different things. So we have the square root of 3 equals x plus 2, and the negative square root of 3 equals x plus 2. For both of those, I'll subtract 2. So I get x equals negative 2 plus the square root of 3. That was from right up here. I just switched the order. Maybe that was confusing, sorry. I could have said square root of 3 minus 2, but it's more conventional to say negative 2 plus the square root of 3. But either way is fine. Or on the second one, negative 2 minus the square root of 3, or negative square root of 3 minus 2. Either way works. So this is an example of one that could not have been solved by factoring. So it's not factorable. Okay, so that's why we need to be able to complete the square, and we need to be able to solve by undoing the square root rather than just by factoring it out. Another way to think of it is that this is a parabola that does have roots. It's just they're roots that are not on integer values or even fractional values. They're roots that are irrational, so they're going through in kind of strange spots on the axis. Okay, so that's all good and fine, but normally something's not already written for you in what's called perfect, or in, square form, perfect square form. So let's take a look at how we can do that. So go ahead and do the first one here. I had you do a Khan Academy on this last week, so this one should be easy for you to rewrite in factored form. Do it now. All right, so hopefully you were able to go straight to x plus 4 squared. We remember that one of those shortcuts that I taught you in that very last week we were actually in class together at good old Selma Middle School was that the 8 divided by 2 squared equaling 16 means that this is a perfect square, and that 8 divided by 2 gives you the value that you add to make your perfect square. Okay, so once we have that, then of course you could solve. So x plus 4 squared, you could take the square root of both sides. X plus 4, the square root of 0, plus or minus 0 is just still 0, so there's only one solution there. So we subtract 4, we get x equals negative 4. So this quadratic would only have one root at negative 4. Okay, now usually things are not perfect squares though. Perfect squares are kind of unique and special and we love them, but we aren't normally given them right off the bat. Now, if you were given something that wasn't a perfect square, we could change the equation so that it was. So I purposely made this one look almost exactly the same as the other one. And we're going to do one step to make it into a perfect square. So take a moment, look at it, decide what that one algebra step could be. Some of you see that if you add 1, that'll give me a perfect square over here, right? Because that 15 is almost to 16. The x squared is the same. The 8x is the same. So let's do that. So 1 equals x squared plus 8x plus 16. Now we have a perfect square. Hooray, huzzah. I've already done this over here, except now it equals 1 because of that 1 right there. So 1 equals x plus 4 squared. And then I do the same steps as over here, except I've got a 1. So square root, x plus 4 equals plus or minus the square root of 1. The square root of 1 is just 1. And then I subtract 4, so I get x equals negative 4 plus 1 would be negative 3, or negative 4 minus 1 would be negative 5. All right, let's try it when it's a little less friendly. So that was 2. Now let's do 3. Okay, so now I no longer have that 8. We need to decide right now that is this a perfect square? And if not, what can I add or subtract to make it a perfect square? So I'm going to look at this value here. We remember that our rule is that if I take half of the b value, it needs to equal the c. So negative 10 divided by 2, sorry, half the b value squared, I should say, squared needs to equal c. So negative 10 divided by 2 is negative 5, squared is 25. Does c equal 25? No, but I can make it equal 25 by adding 5. So I'm going to do plus 5 on both sides. So 5 equals x squared minus 10x plus 25. And then I need to rewrite this side in perfect square form. So since it's a negative 10, then this is going to be x minus 5. Remember, it's a 5 because that's half of the b value squared. And then we can solve from there. So I get that x equals 5 plus or minus the square root of 5, or x equals 5 plus root 5, or 5 minus root 5. I suppose I should say and. I've been using or over around here. Doesn't really matter. Okay, and so this is another example of irrational answers. These are answers that could not have been gotten by factoring, unlike the first two examples we did that were factorable, although we didn't solve them that way. This one was not factorable. This is why we need to be able to complete the square and can't just always use the zero product property. All right, now let's learn how to use completing the square to rewrite an equation into vertex form. All right, so let's start by looking at this example that's basically like the one we did before, where it's almost in completing the square form. We just needed to add 1. And we're actually going to do the exact same steps here, but we'll leave the y. So this is going to become y plus 1 equals x squared plus 8x plus 16. Then I make this into a perfect square. So x plus 4 squared. And then we know that vertex form is y equals x minus h squared plus k. So I need y alone. So I'm just going to subtract the 1 away from both sides. So y equals x plus 4 squared minus 1. And I can see there that my vertex is at hk, so negative 4, negative 1. Okay, go ahead and pause and see if you can do the next one. So rewrite it in vertex form and then identify the vertex. So first thing we need to do is figure out what to add to make it a square. So that's going to be negative 1 squared, which is 1. So that means in order to get negative 7 to be 1, I'm going to need to add 8, because that'll give me 1 as my c value. So y plus 8 equals x squared minus 2x plus 1. So this becomes x minus 1 squared because of that minus 2x. And then I'll subtract that 8 back away. And my vertex will be at 1, negative 8. All right, let's do one more. So the numbers got pretty messy on that one, but the final vertex was negative 2.5, 13.75. All right, so on this one, I want you to solve by completing the square. This one is not factorable, so don't try and solve by factoring. You're going to need to use a calculator or Desmos to estimate the final answer, and then round your answer to the nearest tenth to put into the Google form.